Hello everyone, this is going to be the backup video for lab number 4, and in this lab we are going to use the given database. So you can find the link in the handout file for an ODB database. We are going to use this database with a bunch of additional SQL queries, and this is a basic one, but to check what's going on in this database, a good way of doing it is going through tools and then relationships. So in this view we are able to see all the tables and see how they are related. So in this database we have a bunch of students, and for students we have student groups, so they are S group. And if we were to draw the ER diagram, we do not include the ER diagram, but if we were to draw the ER diagram, there is a relationship such as in, for example, to assign some student to some group. So students are in groups. And for this relationship, we are also saying that every student is going to be in some group, and every student should be exactly in one group. So given these conditions, so what are those conditions? For a student, there should be exactly one group. So that's our condition. Because of this, to reduce the number of tables, we are including the group number for this student. So for example, this is Ali, let's say. And for Ali, there should be only one group, exactly one group, because we have total participation. And this is some one-to-many relationship, meaning that a student should be in exactly one group, but in a group there could be many students. And for that student, for example, for Ali, we are storing the group number inside this table as an attribute. As for the groups, we store the group number. There are names for the groups. And for a group, there is going to be a leader, and the leader is going to be exactly one student again. So if we were to have the separate relationship, we are going to have the group entity, and then leads or has leader, the relationship, it will be connected to the student. But again, this is going to be a one-to-one relationship, and we have total participation on the group side, meaning that in a group there should be exactly one leader. I don't want to have any group without a leader. There's going to be exactly one leader for each of the groups. Again, not multiple leaders, just one leader. Because of that, to reduce the number of tables, we just store the leader's ID as an attribute inside the group table. Additionally, we have a bunch of projects. Projects have descriptions, and they have the project number and a budget. And each group is working on a bunch of projects. This is a many-to-many relationship. So on some project there could be many groups working on, and for a group there could be many projects. So let me also quickly show the tables. So in the student table we have IDs, names, surnames. Each student has an age, and this is the student group number. So which group the student is in, that's the number that indicates that. We also have some payment for each student. In the S group table we have the group names and the group leader IDs. So each of these are some existing students. So for example, if I were to include some new group, I can leave the group leader empty. So while I'm first creating this entry, it should be empty if I don't have any students. So let's say if I were to create this database from scratch, I will have these tables empty, and then I will create my relationships. In a minute I will also talk about how to define these relationships, but I will create the relationships, then I will populate this database. But if I'm first entering the groups, and if I don't have any students yet, for example, if I try to write 30, there is no student number 30, therefore I should not be able to insert this record. So I need to assign some existing student ID in here. That's something to be careful about. So I will just get rid of this one for now. And also for the students, so while I'm creating a new student, for example, if I don't have any groups, I will leave the group number empty first, and then I will enter the groups. When the groups are ready, then I can assign group numbers for any of the students. So going back to the relationships view, this one is simpler. It's something basic that we did earlier. Sorry, I don't want to delete that. So this project is entity, S group is entity, works in is relationship. So while creating these links, I need to start from the existing one into the one that will exist later on. So to assign some group to some project, it is in works in. That project number should exist in the project table first. So in this case, for this link, the parent is project number. Therefore, while I was creating this link, I carry project number into the project number of works in. So this is how I create these relationships. So let me just get rid of all of them. So project number into the project number of works in. The parent should appear on the right side. And I would like to enable the update and delete cascades. So for the other side, the group number, groups, this is the entity. It is going to be the parent. From this parent into the group now of works in. And I will again enable the update and deletes. This time, for group and student, they are both entities, but the roles will switch. So let's first start with the student's ID and the group leader. So in every group, I want to assign some student as the leader. In this case, that student should exist first so that I can assign it as a leader. So in between this ID of the student and the group leader attribute of the S group, which is going to be used as a foreign key. So if I start from some attribute, this is the primary key side, the parent side, into some parts, where I end up is going to be a foreign key. So for this one, the student side is the parent because that student should exist first so that I can assign that student as a group leader. So I will just double click on this link and enable update and delete cascade options. Then for the other side, in order to enter some group number for a student, that group should exist first in my S group entity. So therefore this side this time is acting like the parent. So from the group number of S group into the group now of the students. Since I defined a relationship in between these two tables first, it says that there is some relation already. Do you want to edit it or do you want to create a new one? In this case, I want to create a new one. So I clicked on the create new one and the parent is S group. I know that because it's on the right side, and I will enable update and delete options. Then I save this, and when I come to here, we already populated the database for you. But if you were to create it from scratch for your project, etc., this is how you do it. This is not something much new, but if you want to reduce the number of the tables, it is something that you can do as well. So we are going to create a bunch of queries in SQL view. So we already have the handout file. I'm going to look at the queries from there, the questions, and we will try to implement them. So it says that list name, surname, and group name of all students ordered by the group name and then by student name within each group. So what we would like to do is to select, we would like to project something. We would like to select the S name, the names of the students, the surnames of the students. So each of these attributes are in the student table. We also would like to show the group names for the students. This is the thing, these are things that I would like to project. And if we were to look at these tables, so in the student table I have the group number, but now I would like to project the group name. which is in the project table. So I need to, sorry, not the project table, S group table. So I have the group number in the student table, but I would like to join it with the S group table to get the name, because I would like to project the name, not the group name IDs. So I'm involved with the student table and also the S group table. And I need to specify my join condition from the student side. So remember, for each of the table names, attribute names, we need to include the double quotations for the notation in base. Not for the exams, but for this software only. We are including these double quotations for attribute and entity, or let's say table and attribute names. So in this part we have the group no for a student. It should match with the one that's inside S group. So we are joining these two tables. And I would like to order them according to something. So order by is some keyword that we can use. I would like to first order them according to the group name. And then I would like to order them according to the names of the students. So within a group, so some students are in the same group, I first order them according to the group name, and then within that group I order the students according to their S names. So let's run this query. These are my results. So for these students, these are the groups that these students are in, and if I look at the records are first ordered according to the group name and then according to the names of the students. So let me save this query as query number 1. And let's create a new query. So for the second one, it says that list name and age of student doubles who have 5 years of difference in their age. So I would like to inspect some table. Within that table, to inspect something, so this time the ages of the students, I would like to look at student tuples, 2 different students. In such cases, we need to use cross product, right? I would like to select something from the students. So I would like to project the name and the age. But if I just look at one table, one student table, I cannot do it. I need 2 different instances of the same table. And in that case, I need to give some name for these different instances. So let's say for the first instance of the student table, let's call it S1. And for the second instance, let's call it S2. Then this is going to make a Cartesian product. And so far, if I try to run it, it projects the S name and age coming from the first attribute side. But to make sure that, so I also need to project the student double name. So sorry, student doubles. So list name and age of student doubles, it says. So I need to show it for S1 and S2. So in that case, or if you want to specify some specific part, you need to write the table name before the attribute. So this S name is coming from table S1, this age is coming from table S1, and I would like to get them from the S2 side as well. So I would like to show the other students' name and age as well. If I run this now, then I have this. So for each tuple, so each of these students, I would like to put some condition. And my condition is that for such students, so I have the age coming from the left side, S1 side, and I also have the age coming from the S2 side. I want them to have a difference of 5. So this is what I write here. And if I run such query, now if I check each of these student doubles have an age difference of 5 in between. So we are done. This is our query number 2. So let's continue with the other one. List all group names as well as the average payment of each group. So we would like to list the group names. Therefore, I need the group table somehow. We also would like to get the average payment of each group. And if you check the group table, there is no payment for groups. Groups include students, and we would like to find the average payment of the students that are in that group. So coming back to our query, now we would like to group the students according to the group numbers. That's one thing. Additionally, we would like to project the average payment. So let's write first select, we would like to get the group number. Since we are going to join the student table with the group table, it can come from the student side or the group side. It doesn't matter. Let's get it from sgroup.group now. So maybe it's better if I start from the from part. So we have the student table and also the sgroup table. And since I include two different tables, I'm not interested in the cross product. I need to specify my join condition. My join condition is that from the student side, I have an attribute called group number, group no. This should be equal to the sgroup.group no, since I would like to make the join operation. And I also would like to project this. I would like to show this. Therefore, I include it. Since I make the join, it can come from either side. So I just specified that it is going to come from the sgroup part. It could be the student as well. Then I would like to also show the group name. Group name is coming from sgroup. And I would like to show the average payment. So let's say average of the payment attribute. It's in the student table. We can also give some name to it. Average payments in group, for example. This is going to be the column name. And we have, so far if I try to run it, now we have problem. Not in aggregate function, it says. Okay. So let's try to get rid of this average operation first. Now if I try to run it, I have the group numbers and the group names. It's not a very interesting thing. The problem with getting the averages, it's not because of this as part. If I try to run it now, the problem is if I have the whole data and if I have a bunch of records, then I cannot also include the result of a function. So the problem is that as it is, it returns multiple results. But if I were to just include the average payment, it is going to be just one value. Therefore, if I try to include them both on this line, it causes a problem. It cannot get the average for each of these data, each of these records. So what we are interested in is actually to get this value for the groups. So I'm going to include the group by parts. And what we would like to group by is actually the group number. So I would like to group the students according to the group number. But if I try to run it, it says that maybe it's kind of confusing when you try to read it. But the problem is that I'm trying to project group names, but the group name is not a part of the things that I group by. Remember, we can group by some attributes, then we can only project a subset of those attributes plus the functions. So functions are a different case. We can include the functions with group by statements when you are projecting something. But the problem is that if I would like to project the group name, so let me just get rid of the group name, then it runs, but I don't have the group names. So I include the group name, therefore I need to include it as a part of the things that I group by. then we have no problem, and actually we don't need to project the group numbers as well. We can just show them according to the group names. So if I were to have a bunch of groups with the same name, remember, it's better to group them according to the unique values, according to the primary key, etc. So grouping according to the group number makes more sense. But if I also would like to show the group names, then I need to group according to it as well. So let's save this query as well as query number 3. And then let's create a new one. And for this one, the problem is list name and payment of students that are in the group which has the highest sum of payments. So there is going to be some group. So let's say there are lots of different groups. So we just show the average per group. And if we were to show the sum of payments for each group, we can do it, right? We can write, select the sum of payments from the student table. This is included in the student table. If I just run this now, then it's going to be just one value. It's not for the groups. To do it for the individual groups, I need the group by statement. So let me also write the keywords on separate lines. I need to group them according to the group number. If I'm grouping according to the group number, then I'm showing the sum of payments per group. So if I run it, now we have a bunch of values. It's actually 7 different values for each of the groups, and these are the sum of payments in each group. And if I want, I can just give some name to this column. Let's call it something like pay sum, payment sum. If I run it, the column's name is going to be pay sum. So I have a bunch of values here, and then I would like to find the maximum of these. So this is going to be my subquery now. And if this is my subquery, I can say, okay, just select the maximum of the column that I'm calling pay sum. So the column's name is pay sum in this case. And it is going to come from this part. So this subquery is going to give me a result, and for that result I would like to get the maximum value of the pay sum. If I run it now, this is my maximum value. It returns one thing, and it is guaranteed to be just one value because we are returning the results of a function. It's the result of a function. And then I can, given that this returns a value, if I'm interested in finding this group's ID, so this returns 480. Okay, this is just one value. If I were to know the value of the highest pay sum, I can also find the group number for this group. So how to do that? We can do this. Let's select the group number. I'm trying to find the group number of this group with the highest payment sum. I will look at the student table, and I would like to again group them according to the group number, because otherwise I'm not looking at groups. To look at the groups, I need to group them according to the group number. But then I have a condition for the groups. Remember, if we would like to put some condition for the individuals, we were using where statements, where conditions. But to put some condition for the whole group using some function, we have the keyword having. So for the student table, group the students according to the group number, and for each of these groups, I'm interested in the ones that have the sum of payments that equals to some value. And that value is going to be actually the thing that I find from this subquery. So this whole part becomes my subquery. We know that it returns just one value, and we are going to just use that value here. So let me try to indent it somehow, but it's kind of not that easy in this part since we have uppercase letters or bigger letters, let's say, not uppercase. So this one is going to calculate the sum of payments. It will choose the maximum one among them, and for that maximum I'm going to this time find the group number, which is saying 5. Okay, the group number 5 has the maximum sum of payments. Then I would like to list the name and payment of the students that are in this group. So this is going to return just one value. We already tried it. It returns just one value of the group number with the highest number of payments. But it can also return more than one value, right? There is that risk because we are just projecting the group numbers. It is not the result of some function. So it can return more than one thing. So then I need to compare it using the keyword in. So this can be a subset of results. Among that results, I would like to find the students. So let me get rid of in for now. So what I would like to do is to select the S name and also the payment from the student table. And my condition is for these students to be in the group number that is coming from my subquery. So from my subquery, right now it returns just one value, but there can be multiple groups with the maximum payment number. But even with that, it will return a bunch of things, and I will show the students with their names and payments that are in those groups. So if I run it now, it shows the names of the students and the payments of those students. If we sum up these values, remember the maximum of the payment was 418, I guess, and if we sum these values, it will be equal to that number. And we are done with this query as well. So for the other one, it says that list name, age, and payment of students who are paid more than their group leaders. So for each student, we have a group, and for each group, we have a leader. We would like to compare the leaders to the members, and we would like to find out the students that are paid more than their group leaders. And we are going to list the name, age, and payment of those students. We would like to actually show the leader and the student at the same time. So let's create a new SQL query. This time, so I'm going to select the name, the age, and also the payments. And as I said, we are interested in the student table, and we need the group table as well, because the S group table, because the leader of this group is included in that table. If you check it out, in S group table, we have the group leader included in here. Well, then to compare them, so one side it is the student, but for the other side I need some information from the student table as well. So if I check the student table, the payments are listed here. I need to compare one student with another student. So from the student, let's name it as the member. So let's call this instance of the student table member. We have the S group table, and then we also include another instance of the same table, student table, but let's call it as the leader this time. So right now it makes the Cartesian product, but we would like to join this, right? So my join conditions are going to be for the member side. So this table, I'm calling it member. From the member side, the group number this should match with the group number in S group table. And my other condition is that within the S group table, we have the group leader. It's the ID of the student. So we have group leader. And for this leader side to be the leader student, I need to say that, okay, this which is some student. So for the different instances of the student table, I call it one of them member, the other is the leader. But within that leader table, I want the, so let's check the student table. I want the ID of that student to be equal to the group leader's ID. Then what we have is, with these two joins, we join the member to S group and S group to leader. So we have the join operations. So if I were to run this query, let me also do it for member and the leader. So I'm showing these for the members, and I also want to show them for the leader. I would like to show them both. So I will project the name, age, and payment of the member and the leader. So if I run this query now, I will see that every member is matched with the leader. And we also see the leaders are matched with the leader as well, because they are also a member of the group. Although they are the leader, they are also the members of those groups. But among these, I will have the other condition saying that the member should be paid strictly higher than the leader. So the member, the payment of the member should be strictly higher than the payment of the leader. Then we will also get rid of the matching leaders. So if I run it now, I see that Hal is in some group whose leader is Diego. So for these students, the leader of the group is Diego, and he is paid 45, while the members are paid more than this person. So these are our results. So let's save this query as well and go into the other one. So in query number 6, actually it's an update query, but to use the editor, let's write it here and then run it in some other part. By some other part, I mean that under tools and SQL. So remember, for anything that is not select, for insert, update, etc., delete, we need to use this execute SQL statement window. The other one just works for select queries, but we can just write it here and then copy and paste it into the other part. So it says that double the payment of members of the group who has the lowest sum of payments. Actually, let me get some part from here, not with edit, but with edit in SQL. So remember, in here what we were doing is that we find the maximum paid group, and we were just showing the students inside that group. And in our new query, let's first find the group with the lowest sum of payments. So this actually made it look worse, but let me try to manage it. We don't need actually, do we need the IDs of the students? Not really. Let's just find the group number first. So maybe it would be better to just write it from scratch, but let's try to fix it. So this is the thing that I have. So instead of finding the maximum one, this time I'm interested in the minimum of the sum. So if I run it now, I see that group number 4 gets the lowest sum of payments. And this returns one group number, right? And if I were to update the students inside this group, so to update something, the format is we write the keyword update and then followed by the table name. In the student table, I would like to update something. I would like to set the payment to be equal to the payment times 2. So I would like to double the payment of these students. And for these students, my condition is that their group number should be among the things that I find from this subquery. So this is going to be my subquery now. From the subquery, I find some groups, some student groups. It can be one, it can be more than one. Therefore, I'm using the keyword in. And I know that we just tested that this returns the group number for the one with the minimum payment sum. So it should work. But the thing is, if I try to run it here, it says that it's not a select statement. So I'm going to, it doesn't allow me to save it as well. So let's just continue with that. I'm going to copy this query, go into tools and then SQL. I'm going to paste it here and then I will execute here. So it says that 3 rows updated. So if I execute it again, still it says 3 rows updated, but then it says that 4 rows updated. So I'm doubling the payment of the individual students that are in the group with the minimum sum of payments. Since I increase their payments, after some time, they will be not the lowest sum of payment group. So for those students groups, it will no longer be the one who gets the lowest sum. So then some other group is updated. We see that our query works. We can also go to the sgroup table, sorry, not the sgroup table, to the student table, and we can check that some of the payments are more now. So let's continue with the other one. So let me just get rid of this and create a new query. So this time it says that list name, age and group name. List name, age and group name of students who are in the groups with most member count. So actually it makes sense to get this query again because we have some common parts. So let me try to make it look better again. So what we need to do is look at the count of the groups now. Okay, so this is what we have. Remember, we were finding the maximum of the payments. Now instead, we just want to look at the count of the groups. So instead of saying pay sum here, I will get it as, sorry, let me go back. I changed the wrong thing. So in my subquery, the innerst, the inner subquery, in here, instead of looking at the sum of payments, what I would like to look at is the count of the records. And I'm not looking for some specific column, therefore I include the star symbol. And instead of saying pay sum, let's call it member count or student count, so SC, student count. And I would like to find out the maximum of S count. So for each group I find some student count as SC, and among these SC I would like to find the maximum one. Then my condition is going to be, rather than saying the payment sum should be equal to that, I need to say that, okay, the count of the records count of the students should be equal to this value. And among that, I'm just finding which group number has this count. It can be more than one, but we are just returning one value. It's the results of the function. We are saying that, okay, group within those groups, if I group according to the group number, the count of the members or students in that group should be equal to this value. And it is going to be a bunch of students. And then I need to use the keyword in to project those students that are in those groups. And I would like to project the name, age, and the group name. I remember one problem. We don't have the group name inside the student table. Therefore, I need to also include the sgroup table. But if I also include the sgroup table, I need to make my join operation. So let's say this is one condition. I will combine it with the keyword and my first condition is going to be within the student table, I want the group number to be equal to the one that comes from sgroup side. So this is just the basic join operation. You would like to join these two tables that I'm including. This is the join condition, and the other condition is for the group number of this student to be among these records. So now if I run it, I see that in two different groups, the member count is at max. So these groups are number one and awesomes. And both of these groups have 5 members in it. And these are the students in those groups. So this is going to be our query number 7. And let's create one more query for the final one. So it says that list each project number, description and budget, along with the sum of payments of the students who are in a group that works for that project. So let's try to look at it. We would like to project the project number, so some project now. We also need to show the project description and the budget and the sum of payments of the students that work in a group that works for that project. So let's keep it for now. So the project number is going to be coming from the project table. And for the other ones, project description as well, it comes from the project table, budget comes from the project table. Let me quickly show it. In the project table, we have project number, description, and budget. We are just projecting these values. But for each project, we also need to show the sum of payments of the students that are working in a group that works for that project. So if we check the relationships, students are not directly working on projects. Students are working for projects through their groups. So I need to join project works in an S group with the student table so that I can get these values. So let's first make those join operations. So I'm just going to, not this one, this is the one that we just did. So I'm just going to keep it away for now so as not to confuse things. So let's just look at which student is working for which work, yes. So let's find which student is working for which project. So in that case, the tables I need are the student table, right? I need the student table, and I also need, do I actually need the S group table? Not really. The group numbers of the students are already included in the student table. In the student table, I just write which group this student is working for. But what I need is the works in relation, because in the works in relation I join one group with a project. I join groups with projects through the works in relationship. So if I have these two, I need to make the join operation, right? From the student side, I want the group number to be equal to the one that comes from the works inside. So let me show it in the relationships view. In student, I have group number. Although this goes through the S group table, since I linked the group number in works in as well, instead of saying join works in with S group and then join it with the student table, I can just directly join works in with student, because these are the same values, right? These correspond to the same thing. If I check the parent of this relation, it's S group, and if I check the parent of this relation, it's S group again. So they correspond to the same attribute. Therefore, I can skip the S group and then directly join student with works in. Going back to here. Then from here, what I can say is, then I know that this student is working for the project whose project number I include in the table works in. So I can get the from here I can say, okay, just show me the project number. So if I run this query, it shows me the project number of the students. So in here, I'm also interested in the sum of payments, right? I would like to show the sum of payments of the students that work for this project. So what I can do is, I can group the students, right? I can say group by, and I would like to group them according to the project number this time, because that's what the query is asking, right? It says that list each project number, description, and budget. So these are the projects, along with the sum of payments of the students who are working in a group that works for that project. So I'm showing things according to the projects. So therefore I need to group them according to the project number. And then I would like to show the sum of payments within each one. So if I run it now, it will show me the project number and also the sum of the payments of the students that are working for that project through their groups. So I have 5 different projects. I see 5 different results. Instead of per group, it's per project. But then I would like to somehow also include the information about the project itself. Remember, from the start, we were interested in showing these values, right? From the project table, we wanted to project these attributes. So let me just add it here. But I would like to somehow join it with the results that I obtain here. So for the payment as well, let's name it as something like project sum. So this subquery returns me a result set, and let me rename this result set as work groups, for example. So these are my work groups, and for work groups, so let me just quickly erase this first part now. If I run it, because of this parenthesis, it says error. Oh, sorry, not because of that. Okay, I need to include this as well. So this is my subquery, and it returns a result set. And for this result set, I am giving the name work groups. And just like a table, I would like to get the project table and this table, this whole table, this whole result set. I name it as work groups. And for this one, let me indent it. I can put some more conditions. I would like to join this project with the work groups table. So let's say that suppose that we have some work groups table. Then I can write something like this. Okay, from the project part, the project node of this table, I would like to join them. It should be equal to the one that comes from work groups table. And in here as well, it's called project node. So that can be my query. But there is no such thing called work groups. Then I'm creating that result set with my subquery. So in my subquery, this is my subquery, I get some result sets. There is the project node inside it, therefore I can join it. There is also something called project sum, and therefore I can also say in here also project to project sum. It's the project. That's for the project, not for projection. But this is going to be my query. If I run it now, for each of these projects, I also show the project description, budget, and the project sum. So these are like kind of a little more complicated queries that you might need in the project. But other than that, that will be it for today. Let me also save this query as query number 8. And remember, the handout is also included, so you already have the queries, and you can make use of these queries in your project. And next week, starting from the next lab, we are going to create some forms for users to be able to use our database. So right now we are writing queries, etc. We will create our tables, we will create our relationships, put some data in our tables. But what we want to do is for some users to be able to use our database. And for users, it's not that easy to like go here to get some results. It's actually not that hard to get the results with queries, but when they need to insert some new data to your database, to add something or to update something, let's say with some queries we have the option to update multiple things. For example, in here we doubled the payments of the members with the lowest sum of payments. But this problem could change, and for some basic user it's not that trivial to write such queries. And for such queries we would like to give or let's say we would like to parameterize these queries. So instead of doubling the payment, it can be any factor, let's say, and this factor is going to be some parameter. And for the user to be able to easily use our database, we are going to create some forms. So for forms we have the wizards. So using the wizard, for example, we can include some tables, for example the student table. Which fields? Let's say all the fields. We can click on next, and let's skip the subform part, and we can display our data in different ways. So it can be a table, it can be like this for each user, it displays the attributes, etc. Let's choose one of them. And any entry mode. So do we allow any modification or deletion or addition using this form? So let me click on next as well. We have some styling options. We have the name of the form this time. If I click on finish, this is going to be some window. So for forms, you can think of them as windows of our program. So if I just close it now, it's included under the forms. If I double click on it, it will be open in this view, in this window. Then I can, so these are my results, right, for some user. If I use these buttons, I can go through different records, and for these records it shows up the values. I can change something here. For example, for Liam, let's say age is 19 now, and it changes. If I go back to my student table and look at for Liam, I see that the age is updated. So it gives us a different way of editing our data. But we can also make much more complicated forms. And to do that, we are going to use Visual Basic. So we will use some coding. But with that coding, it will be like we are going to follow some specific format. So in here, I can also delete records. So if I click on this, it says that it will delete this record, for example. I can also refresh the things. I can sort my values, etc. I think I clicked with the wrong button. So for the coding, we are going to use some like strict format, not strict formatting, but some specific things. So we are going to use coding for just some specific things, and those specific things are going to be get some value from this text boxes, use it in some query. If I click on a button, for example, that's going to be just one thing that we are going to use. So with Visual Basic, we are going to use it using some very limited knowledge, let's say. So you don't need to learn a new language from scratch. It's very much similar to the languages you have seen in the university, and we are just going to learn some functions and how to apply them in the next lab. So see you.